Good morning, good evening, good afternoon. Today we've got a great session about app deployments with Azure Service Operator with the great Daniel. So thank you for coming and presenting on this quite interesting topic to us today.
That's always a
Before we
pleasure.
get, yeah, thank you. And we were just talking about how it's 7:05 a.m. New Zealand time, but it must be 7:05 p.m. where you are, right?
It is definitely, yeah. But it's back in
So,
time. So it's
but back
Thursday
in,
evening
yes,
here and Friday morning for you. So yeah.
yeah, I always laugh because it's like, oh yes, we're closer to the weekend, but that also means when the weekend happens, we're closer to going back to work. So it's a catch-22. Yeah, yeah. I like it on a Friday. I don't like it on a Sunday. But just some housekeeping. So this event is delivered as part of Azure Cloud Commander. So this is a Microsoft Learning Room. So within the Microsoft Tech community, you can go under Microsoft Learn. You can go to groups. It can be a bit hidden. It's mid down the page. They've also changed the UI, so I need to update the screenshot, but it's still the word groups. Within that group, you've got a bunch of learning rooms. So these learning rooms contain subjects around data and AI, Power Platform, Low Code, Azure architecture and administration, which is really where my learning room is focused on, which is the Azure Cloud Commanders. So it's a pretty open space. You can raise discussions, share knowledge with each other, and this is where you'll be able to see events such as this. So definitely check it out because we've got a lot more events planned to deliver to you, especially going into the next calendar year as well. I'm hoping to really ramp up and get this going because we moved recently from our Microsoft Teams community into the tech community as well. So still figuring it out, but this is an open space. There's no need to register for anything. So welcome aboard. This session is being recorded for the people who can't make it. So if you do have a chat question, which I do encourage you to do because I'll be monitoring the chat throughout, then I may take it and then display it on the chat. So just be wary that if you do include anything with organizational context as an example, that may make it to the screen. So just be aware of that. We're all here to learn. We come from different backgrounds, different knowledge. So just, yeah, have fun, be curious, ask questions, learn. I'm quite excited about this session myself, so I'll be keeping a very close eye on what I can learn from it. With that said and do, I would like to hand over to Daniel. So thank you again for coming to present to us today, Daniel. Looking forward to it. So yeah, do it if you want to just go into more of an introduction and take it away. Thank you.
Of course, of course. Thank you. Um, so before I tell you a bit more about me, I want to tell you a bit more about how I came to play with the Azure Service Operator and why I started to use this. Because I'm a consultant myself, so I work for lots of different teams, and one of those companies made a lot of use of Terraform. And while I like Terraform as a tool, um, the way that they implemented it, they had lots of small Terraform repos. Every team maintained their own part of the infrastructure, basically, um, which again might actually be a good thing. However, because there was so many small repos, there was so many uh, yeah, broken up pieces that it became an annoyance, and we were investigating how could we make this work, how can we improve the developer experience, and it was actually an organization that also made a lot of use of Kubernetes, especially AKS, that it made a lot of sense to start to look into if we could utilize the Azure Service Operator. So with that being said and that introduction being done, um, I like to set the stage a bit. So I did this talk once but in Dutch. So if you find on the slides any Dutch, I'll explain it. I think I made sure that everything now is English. So, but please bear with me. Um, Today we're gonna talk about what is AKS, because you might never have heard of it or have used it. Then I also need to explain to you what an operator is before we can talk about what the service operator actually does. So what is it and how does it work? I'm also going to explain to you what the difference is in using the Azure Service Operator or Terraform versus Bicep. We talk about use cases and best practices a bit. There's definitely things that you need to pay attention to. So let's talk about pitfalls. And of course, I have a demo. We will start the demo small, and hopefully the Redis instance that I'm currently am deploying will actually be deployed when we come to the demo. Then a bit about me. My name is Daniel Paulus. I'm the head of Azure Solutions for a company called The Factory. That's why you see the nice TF. That's not for Terraform, it's The Factory. And I'm also a Microsoft MVP. So why would you do this, right? It's a little bit the same as the introduction I did, but more and more we see teams which used to be developers and operations, and we see them coming more and more together. One of those reasons is because when they deploy applications which in a cloud native fashion, they need to understand how pods work, how networking works, how do we deal with secrets. And of course, we can say that's for platform engineering, and so that's for platform teams. But in my mind, a platform team simply provides the platform. So the Kubernetes cluster where we're working on, it doesn't actually deal with your app. So as a development team, you need to understand what are all these resources and how can I utilize this. But if I need to deal with Kubernetes resources and with YAML all the time, then why do I also need to care about this Terraform thing? I want to care about like having the same spec in the same repository, one-click deployment, no headache, like just go. And the most important thing, I hate state issues. And yes, you can tell me that with Bicep you have no state issues, but still, it's not the same as a Kubernetes resource. So having that said, having all these people nowadays that understand how to deal with Kubernetes, why can't we make it a first-class citizen? But let's do a step back, right? What is AKS? AKS is the Microsoft opinionated version of Kubernetes. And I especially call it like this because it is the main, it is based on the open source version of Kubernetes from the CNCF, but they have made some tweaks to make it run better within the Microsoft Cloud. The nice thing is that everything, or okay, not everything, but a lot of things, and that is growing, is actually running on AKS within Microsoft. So we talk about Teams, we talk about Bing, Xbox, online services. So I play a lot of games. I have a Game Pass. It's powered by Kubernetes. Copilot, it all runs on AKS. The link down below, you can read more about this. They don't make it a secret, and it will definitely be growing. It is a version of Kubernetes, or it is a Kubernetes cluster without the control plane for you to manage. So in a bare metal setup, you would have to have the control plane. You have to maintain that. You have to care about it, especially about the database components at CD. And with AKS, that part is managed by Microsoft. So the only part we care about is the actual worker nodes. And of course, the nice thing, It integrates with Azure AD, networking, and monitoring. And it also gives you a lot of add-ons and plugins that Microsoft maintains. So Flux is one of the add-ons that you can install, but also they're now working on Argo CD. I think it's in preview. You can actually use it. And that takes away a lot of the complexity of day two operations for Kubernetes. So having explained to you what Kubernetes is, then it's also important to explain to you what an operator is. And you could say that me as a platform engineer am the operator of a cluster. Yes. However, the operator I want to talk about is a application, a container that runs inside of AKS that does the same thing like I would do, only does that automatic. So it understands. So I give it an assignment, which we have made with a custom resource definition. So I explain a object to the operator, and that operator is constantly checking, do I need to do something? That can be, do I need to roll out a new application? Do I need to restart an application? Is the server still healthy? Do I need to do anything? And you have a bunch of operators nowadays. There are operators for PostgreSQL, for all kinds of databases, but also for dealing with Azure Service requests, right? But another really known one is Cert Manager, which if you have an ingress and you would like to have an SSL certificate, it goes to a authority, asks for a certificate, gets the certificate back, and loads it into the configuration all by itself. So you don't have to care about SSL certificates anymore. This is a really good example of what an operator does. And because it's a resource definition, it's always the same. So it's really declarative, and it has the domain knowledge to deal with all the stuff behind your request. So what does then make the Azure Service Operator? It is a specialist that can manage Azure resources. Done. That's what it is. But if we make that a little bit more interesting, it basically means that just as with Terraform, you can specify that you want to have a key vault and you want to have it deployed in a certain location. The only difference is you do that in YAML, you deploy it to the cluster, and then the cluster understands, oh, wait, let me get going with this. Same for storage accounts. Every object that we can make in the portal, we can also create with a CRD request to AKS. There are two versions of the Azure Service Operator. Version 1 is deprecated. It was a home-built proof of concept from Microsoft to see if they could do something like that with an operator. V2 is based on the technology of Crossplane. And Crossplane works for every cloud provider. And Microsoft made a fork of this and made it Azure native, first class citizen, and Azure native. So V2 is the service operator that you want to use. I believe they use the Open API spec to make sure that everything you can do with the API calls, you can do with with the specifications. So not like with Terraform, where we have to wait till someone makes a pull request and updates the resource with the new possibilities. Day one, you have the support, which is more or less like with Bicep. You have you have multiple ways to authenticate with with Azure. One of the ways would be workload identity. So it's something that the cluster has, that you tell Azure, okay, this cluster is allowed to deploy the resources. Or you can create a service principal, and in the end, it creates ARM resources. So one of the things you have to care about is what level of access do I give this operator, and to which namespaces or resource groups do I give access, right? You can give multiple teams their own separate service principal and control the deployment like that. In my demo account, I have a service principal that is a contributor to my subscription, which is definitely a bad practice, right? You want to limit the scope of what the operator can do, because anyone could technically deploy everything. So how does it work? Like I explained before, it runs a set of CRDs, and a CRD stands for a custom resource definition in your cluster. And this can be something like storageaccounts.storage.azure.com. Then the controller, which is a container, is written in Go and is just checking every time, is there a new resource? Is there a new resource that I have to deploy? Then if there's a new specification, then the controller picks this up, makes sure that it parses the YAML to an actual ARM API call. And if we're done, it has sent it to the ARM deployment endpoint and created the resource in Azure. It also checks the status of that action and writes back the status back into the AKS object. So how does that look like? On the left, or at least on my left, you see what the specification would be in YAML. On the right, you see Terraform, right? So the difference is not really big. It looks a lot the same, right? So in the API version, we specify that it's an Azure API object, and this is the API that I wanted to use. It's a resource group. The name of the resource group is my resource group. The namespace is default, and the specification is the location is in this case West Europe. So the thing is that with the only weird thing here is that I have to specify a namespace, and the namespace is the Kubernetes specification that tells it in which namespace it will be deployed. If my team is called any different, I would maybe use namespace team name, right? Or something like that. You see underneath, we specify the storage account, and this is also going to be deployed in the namespace default in West Europe. But what we do is we put it in my resource group, and we specify that with the label owner. So you can stack the resources that you want to deploy. As you can see, it's just a standard LRS type, and the access tier is hot. So we can change that however we want. But the nice thing of this is, let's say we're using GitOps, right? And I have this application that needs to use an Azure storage account or a Azure queue, or just think of something. We could put this next to our deployment of our container, make sure that everything in Azure is deployed and is ready before we actually started the container. So no more synchronization of pipelines or changing something in Terraform first before we do something with the application deployment. It could be all in one deployment, basically. It's more in control of the development team. The loop is way closer, so if something goes wrong, it makes the testing a lot easier. Same for Bicep. If you're more into Bicep, it would look something like this. Actually found something in Dutch here. The description is the name of the research group, and the location for the resources. And then the third description is the name of the storage account, and it has to be unique. That's the translation in English from this Dutch. So as you see on the left again, the storage account and the resource group. On the left, on the right, you don't see a storage account because in Bicep, the storage account has to be managed differently. So let's talk about the use cases and the best practices, right? We have played around a lot with this. So this is what worked for us, but it might definitely not work for you. But each team gets its own namespace in Kubernetes. We don't do separate clusters. We don't we didn't do different node pools, but we started to do that anyway. But the most important thing is it's namespaced in Kubernetes, and not everybody gets its own cluster. There's two reasons for this. One, for our organization, small team, we wanted to make sure that we didn't have the management overload of multiple clusters. And we all know that compute resources in Azure are a bit limited. So we wanted to make use of the space we got and not try to use as much as we could. They can create the Azure objects within that namespace, but they don't get access to Azure portal or infrastructure of code as code. In the end, we ended up with some teams having fewer access in the portal, because that sometimes is handy, especially with debugging. But we wanted to make sure that they only had to care about what happened within Kubernetes. This does give the team the autonomy that they need, and especially want all the time, while we maintain the control with RBAC and policies and GitOps, right? It would make it too big to now go into the policies and the GitOps part. So we're just gonna look into this specific, how do I deploy a resource from a namespace to Azure. But if we would look into GitOps, it perfectly fits within a setup like Argo CD or Flux, as I already shared with you. So you define all your infrastructure in YAML in a Git repo, which gives you complete audit trails, who changed something, what was the commit message, why was it changed, who pushed it to the cluster, everything with RBAC, and everything happens within AKS. Especially when you work with temporary environments, there are multiple solutions that you can use to spin up a fake Kubernetes cluster. You could also deploy the Azure resources and make sure that it all tests and is nice, and it will be automatically cleaned up as soon as the namespace is deleted, right? So what are some of the pitfalls and the attention points? As we all know, some Azure resources require unique names globally. There's no confirmation of this upfront. So sometimes the deployment doesn't work and you have to figure out what's going on. The nice thing is that it writes back to the object status that there is a problem and what the problem is. I must admit, we all know that Azure isn't great in telling you what the problem is. That's the same because it's using the same error messages. They also use something like a status condition to report you on the errors. So you often need to use the kubectl describe command to see more detailed error messages. When you create something at scale, please know that there are Azure API rate limits. I have hit them in the past, especially if you redeploy a AKS cluster with GitOps and then deploy a bunch of apps into it. You will see that it takes a while before everything smoothly runs. And it has to do with the API rate limits. Another very important thing to note here that's not on this list, the list of resources you can deploy to Azure is extremely big, which makes that the list of CRDs is also really big. It is not advisable to use a free tier AKS for this. Go to standard or maybe even a premium tier, and know that if you really need all the resources, it's gonna hurt you. I'm gonna show in a demo how you can limit this. And I would also advise you to limit it because if you give all the freedom in the world, it will definitely be used. So what we did is we made sure that we had a list of things that were allowed to be deployed, and only those CRDs were active. Was something added to the list, we would enable that CRD in the cluster as well. So it was not a hard lock, but it was definitely something to keep some control. And if someone modifies the resource in the Azure portal or by Terraform, the Azure Service Operator can detect drift and correct it, but it can also crash if that fails. So I'd say make sure that you have one thing that modifies all the resources and keep using that, or use something else, but not use multiple things updating the same resource in Azure. So it's time to start to show you how that actually works. I'm going to stop sharing and share my terminal. Share screen.
May the demo gods be with you today.
I hope they are. I hope they are. No front door issues, hopefully. Or is that too soon?
Yeah, maybe too soon. Yeah. Is that bringing up anything? thing. Something. Oh, there you go. It's a
Okay.
bit
Yeah, I'm gonna zoom
small
in
though.
a bunch. So yeah. Okay. Maybe a little bit smaller because now I can see it. Is this good on the screen?
Yeah, what I'll do is I'll make it full screen as well, so it'll hide you, but it'll be
That's fine.
easier
That's
for
fine.
people to see
I
it.
am not interested. The like I am not interested. The screen is. So what are we gonna do? I have a Kubernetes cluster, and this is K9S, which is a viewer that you can use in the terminal. So this is a special AKS cluster that I've spun up, and in this AKS cluster, you see Cert Manager running, which is needed for the endpoints, so that it's all HTTPS, and you see the Service Operator system running. It's two controllers. What I did, I created this. Does it show? Yeah. I made this with a Helm file. So as you can see here, I deploy JetStack for the cert manager and then the Azure Service Operator. We pull that from Azure slash Azure Service Operator from GitHub. And the only thing we do is we limit the amount of, let me make this a bit smaller. So we tell it explicitly to only deploy the CRD patterns for resources.azure.com, for Key Vault Azure.com, for storage, and for cache. So basically, the only things I can deploy right now are resource groups, key vaults, storage accounts, and caches. Right? If you need anything else, you need to make sure that the API for the CRD pattern that you want to deploy is included in this list. We could, as you see a star here, we could make it even smaller, but I would say just do star because this way you already do a lot of limiting what you actually can do. So as you can see, in my default work or in my default namespace, there's no resource groups yet. There's no pods, there's nothing. I made a definition for a resource group, which is exactly the same as you saw in my presentation, right? It's gonna deploy a resource group in Azure called ASO sample resource group. We're gonna put it in a default namespace within the cluster, and it's gonna make sure that the resource group is made in West Europe. I might be able to. Does this work? Maybe it's group. I always am struggling with the AZ command. Group. It actually is, but let me show that in a table. So you see there's a demo namespace where my cluster actually runs in, but there's no sample RG. So we're gonna deploy from a file, and the file is called resource group. And now you get the answer back that it has made a resource group object. So if we now look here and we filter on resource group, we have a resource group, making this a bit bigger. So if we then look into the description of this object and we go down a bit, you see that it took the credentials from a secret that I've made on the Kubernetes cluster. And it started to do a create or update call. and it has talked with Azure and created a resource group. As you can see, this, of course, is really fast. So if I now do, once again, the list, we now have a sample RG, which I think is a super simple example. This is super fast because it's just a resource group. And as you can see, this is the only resource which is in West Europe. Everything else is somewhere else. But just the resource group is also a bit boring. So why not make sure that we also deploy a storage account there, right? So as you can see, this is the storage API. It's a storage account. We give it a special name. Hopefully it's not in use now. We want to deploy it in West Europe with the owner as a sample RG. We could specify more properties. I'm not going to do that for now, but just to show you that you could technically specify that it's not a public tier access, and that you want to do SSH only, or HTTPS only, and you could also specify an access tier. Okay, so let's deploy the storage account. So if I go here, storage account, it's not ready yet, which is fine. It's starting to create. It took, once again, the credential, and now it's making it. As you can see, it takes a bit longer, but now you see that it's ready. And it has made it. So if we now check AZ, I think store. Let's see what happens here. Like that. If I want to show my browser, I have to reconnect again. So what is it saying? Storage account, manage storage accounts. Yes. Why don't you give me an overview then? Oh, of course, I need to specify the resource group. And here it is. So it is actually deployed. This is all fun, but this is all like easy stuff, right? We have a resource group, we have storage account. Yeah, fine. But now let's look. I also created a bigger thing. Let's deploy the vote app, right? We have created a vote app, which is using Redis. And it's first gonna make sure that there's a namespace within the Kubernetes cluster. So this has nothing to do with Azure. But then it also needs to make sure that there's a resource group in Azure, especially in West Central US, and it's gonna take the app name from my environment files. And because my application needs Redis, I want to deploy a cache, especially the Redis cache, in that namespace. And I can specify the entire SKU. So it's C-based, it's basic. We don't do any load. I want to make sure, because I don't want to deal with SSL, so insecure. We're going to put some configuration in Redis. And this is the important part. So I'm going to tell the operator, if you deploy Redis, you get back a hostname and a primary key. And my application needs those two things in order to work. So please put them in a secret. And the secret is called hostname and primary key, and it has a name and it has a key. This is managed by the operator, so I don't have to care about doing all the secrets management. Then we're going to do a deployment in Kubernetes. So we're going to deploy a container. And here comes the fun. We're going to load it from my own ACR. And there's two environments that we're going to expose inside of the container. One is Redis, which is actually the host name, and the other one is the Redis password, which is the primary key. And we want to create a service so that I can connect to it. So let me check, because this is what I did before we started. Because the thing of Redis specifically is that it takes a while before it's deployed. So the app seems to be running. Making this a bit bigger so I can try and see. Seems to be good. But let's look at the cache, right? So we've deployed a cache. It reported back that it was ready, which is nice. Let me see. So it took a while before it actually succeeded. And that's why I started it before the presentation, which is great. So now we would be able to expose the port. Let me zoom out a little bit, because I always have to service. And I want to expose the port forward. Port forward is Shift F. Oh, now I have to go here. Stop sharing for a bit. That was the wrong button.
Welcome back. Yep.
Yeah. Share screen and window, and then this one.
With great power comes great responsibility, right?
Yes, it's a really big
Technology.
red
It's
button.
like, yeah, oops, wrong button. Front door outage. Ooh,
Ooh.
yeah.
But as you can see in this page, is that we now have an application running. Dogs. Cats. And if I now go to the Azure portal, we actually see here that Redis is deployed, right? It's running. It's a light instance. You see that the load is coming in. So this is exactly what we wanted. And with that, I'm basically at the end of the presentation. We can go back
That's
and share you that YAML file again that I made to deploy this. But that's all the demo that I have to show. So if there are any questions or remarks or anything, now is the time.
Yeah, any questions in the chat? Not yet, but I'll just put up the Q&A image. So if there is a question that you have, feel free to ask it now within the next couple of minutes. But yeah, that was great, and not a single Terraform or bicep, or even got like ARM syntax at all. YAML makes it a hell of a lot easier because you can actually read what it's doing, and then understand the connectivity as well. One of the things that was quite interesting for me was primarily the Azure infrastructure side of it, but how did the application code, like, because you were hosting that on localhost, right? But then you were connecting to the cache that you deployed using the service operator in Azure.
Yeah, so I'm sharing my screen again. Yeah.
Yeah,
So what we basically do is, right, I run everything I do in dev containers.
I love those dev containers. Yeah.
So I have a dev container that has a bunch of extensions enabled. One of the and a bunch of features enabled. One of those features is K9S. That's what you're seeing here, right? And I have something called dir-env. So I am able to expose to my environment really easily my credentials to connect with Azure, basically. And one of the options you have inside of K9S is do an actual port forward. So you can connect from localhost through some kind of a tunnel to your container, or no, not to the container, to the pod, basically in Kubernetes, and then access that port through your connection. So it's super easy to debug.
That's pretty cool because the dev
Yeah,
container will then open up those ports as well.
yeah,
And
yeah,
so automatically you have an
yeah,
ingress point to connect through.
yeah, yeah, yeah. And it's not public. It's just through a tunnel, so it's just for you. No one else from your company can connect to it. It's just you. And I use this a bunch to test, especially if there are SSL errors or ingress issues, to see if it's the container or if it's the actual ingress. And usually it's a misconfiguration of the ingress, basically. So you
Oh,
do
cool.
have, I think you
Oh,
do need to have a service though. So you have to specify a service object in AKS to make this magic work.
okay. There's no questions in chat, but I do have a final thought is really about scaling this out. So for example, in the demo, we've deployed the resource group, we've deployed the Redis cache. That's fine for one use case. But if you're looking at what would be the implications or the thoughts around, okay, well, we've deployed this app. So we've now deployed the voting app, but now we've got another app or another service to deploy potentially for another team. Is there any final thoughts or gotchas around how would you scale this out? And I'm thinking more around kind of platform engineering, enabling teams, enabling deployment
Yeah.
without having to rely too much on infrastructure as code to do the deployment, because this is more of a push and a pull mechanism. So
Yes. So if you want to scale this, I would make sure that you start to use things like GitOps of course, right? Every team is in their own namespace. That's important. Um, so especially in larger organizations, I am used to the fact that every team already has their own space.
Mhm.
And that is usually the name of the app that they make, something like that, right? And you can technically make the operator work within the namespace of a team. So you could deploy multiple instances of the operator. So let's say it's going to be extremely busy. You have 150 teams.
Yep.
That's too much for the operator to handle. The operator can scale, but that's going to be insane, right? Because lots of changes, lots of reconcile loops. So then you would go to multiple AKS instances.
Mhm.
We can technically also utilize Fleet to deploy an application to multiple clusters, right? I haven't looked at that use case yet with the Azure Service Operator, but
Well,
technically it would
still
be
bound a lot by the like essentially all this should be in GitOps anyway, or in version control. So you're still bound by how that's architected as well.
yes,
And so you almost need like a parent-child repo relationship
yeah,
to try and,
yeah,
without having everything in one repo across multiple teams, right? That can get messy really quickly.
that will definitely. So what we did, we used Argo CD,
Mhm.
as that has a dashboard, and at the time Flux didn't. So we went for Argo CD, and every team got their own project, and then had the application deployment structure. It's a GitOps way of thinking, right? So they had one folder that contains their entire application, with all the subsets and everything that was needed to deploy that. We as platform team were the ones that made sure that everything that they needed was there. So we made sure that Cert Manager was there. The operator for Azure was there, but also the logging, the metrics, everything around that part was sorted. So the team only had to care about how do I deploy my app, and that was their GitOps, their GitOps flow basically.
Well, thank you for coming and presenting an interesting topic with great demo with us today. Thank you for giving up your afternoon in order to present. And yeah, thank you for rescheduling as well. I know.
Yeah, of course,
Stuff.
Thanks for that flexibility, and it was a pleasure to be here.
Yeah, awesome. I'll end this stream, but thank you very much for coming and presenting. Really, really useful.
All right.